Welcome back to Best Practices. Today we will be diving into multiplication models in third grade. I am Michaela Guarniello. Take a moment to look at this meme. Third graders, when they're the first to memorize the 12 times multiplication chart. We've all been there. We may have been this student where our heads are exploding under the pressure of finishing those mad minutes, or we may have even been the teacher that's administered those assessments. We have to remind ourselves that quick recall and memorization does not equal understanding and deep knowledge of a concept. Students are going to be exploring and understanding how and why we multiply to find products. Throughout this unit, we will be looking at a variety of multiplication models, starting with arrays, equal groups, area models, and equations. Here are some examples of some. Let's take a look at the word exploring. If you notice, we don't say or use the word fluently. In third grade, the expectation is not for students to fluently multiply. However, but more to explore and have manipulative, hands-on experiences to understand the concept of multiplication deeply. Students will explain examples of different models and how they have found their products, and as well as determine if two equations are equal to each other or true or false. We will now take a look at what student learning can look like in the classroom. We first have an example of a student modeling equal groups. They've created 5 groups of 7 and then follow it by writing the equation to match to show that they understand that there are 5 groups of 7 making a product of 35. Next, we have arrays. The students can take images and arrange them into rows and columns, then record their model visually to draw their display, and follow up by writing the equations to match. When it comes to these concepts and models, we're looking at MTRs 1, 5, and 6. MTR 5, using patterns and structure to help understand and connect mathematical concepts. When we think about multiplication, it is heavily based on number patterns and understanding how those patterns connect. Finally, with 6, assess the reasonableness of solutions. When students use hands-on models and manipulatives, this will support students understanding if their responses are reasonable and match what they have created. What does student learning sound like in the classroom? Here we have 2 questions that we'll talk about of what it can sound like during class discussion and multiplication models. Our first question is, how are the models and multiplication sentences related? Here you can see we have an array of 3 rows of 7, and that makes 21, showing that 3 times 7 is 21. This is an example of how a student could describe how their model matches their multiplication sentence. This can also be done with equal groups as well as number lines and all the other models we've looked at. Our second question, what is the relationship between the equal jumps on the number line and skip counting? I like to tell my students that our jumps equals our other factor, and how many mini jumps we do inside is our other factor. So here we have an example where there are 2 jumps to get to the product of 16. And as we notice, the halfway point is the 8. So that means there are 8 smaller jumps on the inside. So 2 big jumps times 8 small jumps equals 16. There's quite a bit of vocabulary that comes with multiplication. So let's take a look at some of the words that students will need to be familiar with. We have area model. A lot of these we will notice are the models that we are going to be working with, and this is an example of one of the models students can use to support in solving for multiplication problems. Array, another model. Equal groups is another. Equation. Keeping in mind that an equation must have an equal sign, whereas an expression does not. This is often a misconception for students and can easily be mixed up. False, not true or accurate. The word multiplication, the operation. Product, true. Student learning can be demonstrated in a few different ways. Here we're going to take a look at some samples of student work. First, we have an exit ticket, final cupcake design. Students are to read the scenario and determine whether 2 children have an equal number of cupcakes by modeling and finding the products for each student. First, we can notice that the student uses a tape model to demonstrate 8 times 8. and then equal groups for 6 times 10, showing that they understand how to use both models. The student then concludes that these equations are not equal to each other and then justifies the reasoning at the bottom when selecting the word false. Next, we have notice and note. Here we're comparing and contrasting different models. Students can describe how models are similar and or different. Then the second portion, relationships. Students are taking connections of two models and seeing how they are related. In this case, they are looking at repeated addition and their multiplication sentences. Keep in mind that students are not required to memorize their facts in 3rd grade anymore. These benchmarks are to ensure there's a strong foundation at the bottom built so that we can truly understand the concept of multiplication and then, in the future, memorize their facts. On this portion, I want to really highlight MTRs 1 and 5. 1 includes actively participating in effortful learning, both individually and collectively. We can see that students can do these activities independently as well as a team, and they're using their collective knowledge of multiple models to determine products and explain their thinking. MTR 5, use patterns and structure to help understand and connect mathematical concepts. Here we can see an overarching connection from simply modeling and finding the products, then to justifying why they have selected a specific answer, and then comparing, contrasting, and connecting. Here we have some more questions to ask to deepen understanding. Our first one is the equation 5 times 6 equal to or the same as 30 plus 6, true or false? A sample answer from a student could be, the equation is false because you must solve both sides of the equal sign and they must be balanced. On the left side, the product is 30, but on the right side of the equal sign, the sum is 36. This question is really important and to stress the understanding of the equal symbol, and the student clearly has a strong understanding of it, that the equal symbol means the same as. That way students understand that both sides of the equations need to be the same as each other. Our second question, similar with an equal sign and two equations. How can you prove that 56 divided by 4 is the same as or equal to 7 times 2? An example could be from a response from a student. The equation is balanced or the same on both sides. I know this because 56 divided by 4 equals 14 and 7 times 2 equals 14. In both questions, students are justifying their reasoning to understand the value of each equation. When it comes to the MTRs, we are hitting 1, 4, 5, and 6. I want to focus on 6 right now, assess the reasonableness of solutions. When students look at these types of equations and questions, they will notice that if it's unreasonable, where, for example, the first one, 5 times 6, is the same as or equal to 30 times 6, it wouldn't make sense to say that those are both the same. So they're really looking and evaluating whether their responses are accurate and reasonable. So how can we support our students with these concepts at home? Here we have a very simple example and task that can be done called You Pick the Model. A student is posed with a word problem. There is a starter there to utilize, and the child can pick any model that they would like to solve it. We have options of equal groups, arrays, take diagrams, number lines, equations, repeated addition, and these are all concepts that have been discussed throughout the benchmark. Therefore, students, when reinforcing these concepts at home, should quickly be able to do so with some examples and support. Our time's up. Thank you for joining me on the exploration of multiplication models. We'll see you soon for more best practices.